Hola a todos, buenas tardes. Vamos a seguir con
Good afternoon. We will now continue with the afternoon session. Ernesto Sanchez and Henry Godoy. Ernesto Sanchez is from the University of Salta. He is a faculty member and researcher from the Catholic University of Salta, and Henry Godoy is
¿Puedes exponer acá? ¿Me dejas libre a mí? Yo necesito este espacio para iniciar mi laboratorio. ¿Tú puedes arrancar la exposición acá?
Boa tarde a todos.
Good afternoon, everyone. It is a pleasure to be here once again in the LACNIC Technical Forum. I'd like to thank the program committee for having accepted our paper. It is a pleasure to be here with my friend Ernesto in this collaborative project between the universities Universidad Católica de Salta and the Unicamp, the National University of Campinas, the State University of Campinas. We have a lot of technology here. The objective of this presentation, where is the timer? All right, so the objective of this presentation, very briefly, is to promote a space. Well, we'll be having a second presentation of this program, but as I was saying, the objective is to set the context of what Ernesto will be doing later on. He's going to be making a live lab. But so we can better understand the lab, allow me to make an introduction of the ICMP protocol and the need of having some kind of filtering for the ICMPv6 protocol. It is always good to understand why protocols are created and also the objectives and functions. In the case of ICMP, this was created to provide feedback on problems of the IP protocol. This is a protocol that isn't reliable in terms of its transmission. So this ICMP was created to provide this feedback and also to inform on errors and controls regarding the network. This is described in RFC 792. So ICMP will assist IP in its basic functions. On Tuesday, we had a presentation by Thomas Lynch. He introduced this topic. He made a great presentation. And this also helps us to set the context. Everyone has already used a ping command or trace route. This is the most basic command that we have, and today, in order to try network connectivity, we end up using a ping to do a connectivity test. So over time, several habits were created. 30 years ago, those called Internet Access Providers in Brazil, the ISPs, started to provide commercial internet in Brazil. And over the past 30 years, previously we received public addresses for all because there was a large amount. So we tried to understand why so many people started to block the ICMP protocol. We realized that over that same period of time, DDoS attacks started to occur. So there was an indiscriminated blocking to that ICMP. This was also because many wished to conceal the network technology. That is why we had this indiscriminated blocking. As a result, several scripts and tutorials were created, and this began a practice, but without explaining too much why this ICMP was being blocked. However, when IPv6 came up, there is a mistaken concept regarding the use of ICMPv6. This is because many still believe that this is a ping with a higher address that we use in the network. So in fact, ICMPv6 received a lot of features, of functionalities. It's much stronger and also has critical functions such as neighbor discovery, router advertising, and PMTUD. And this is, as is commented in RFC 4443, many administrators end up having difficulties to adopt IPv6 because they cannot block the ICMP, and they end up not going over to IPv6 because if they were to block ICMPv6, they will be able to implement IP in the network. Very rapidly, as I highlighted, IPv6 replaces the famous ARP, which was done through broadcast. And via NDP and multicast using the FF02::1 or FF02::2. And this leads to a lesser burden on the network and a higher efficiency in the communication between devices. These are a few considerations that Ernesto will explain and share with you. ICMPv6 has several messages. Many of these messages such as router advertisement occur, for example, when we use Slack and unicast, but most of these are multicast in the network. These are the messages that were added to the ICMPv6 protocol. These are messages for learning and delivering IPv6 addresses, and also the network discovery network. These are messages of ICMPv6 that still inform of errors that are defined in RFC in one of the RFCs. So this is the purpose of our research. ICMPv6, we are aware, is also responsible for the router advertisement messages and delivers the IPv6 message automatically and stateless. What we see is that in those types of deliveries, there is a kind of abuse that is made. So our objective, therefore, is to do secure filtering using IPv6 protocol. Sometimes it's important to combine it with DHCPv6 and SLAC in order to deliver an IP address, and also combining the flags of the RA messages. This will allow us, this is a capture with a Wireshark, as you can see. So the impact of full blocking of ICMPv6 in the network are these. The network can fail, it won't receive the IPv6 addresses. There will be problems in the path MTU discovery, in addition to diagnosis problems of the network when carrying out a ping or a trace route. Ernesto will now speak about the recommendations for filtering, for the secure and correct filtering of ICMPv6 that we have tried. In RFC 4890, different scenarios are described in local traffic that go through our firewall. So Ernesto will now share with you some of the techniques. Some are well known, such as RA guard, IPv6 snooping, and how this filtering can be done in a secure way. So now let's go over to the Zoom. Ernesto will make a live demo of this laboratory. Ernesto, you have the floor. So we now embarked on the challenge as to what is the best way to show what we do. What best way other than having a live demo. So let me tell you that we analyzed this using a network security auditing tool, which is DHCPv6 snooping. We analyzed an attack in order to determine which is the best way to mitigate each of these. The conclusion is that there's no one single methodology or means, but rather a combination of all these available mechanisms.
Another objective that we proposed was to show the marvelous things of the container lab, this tool with which I put together a virtual lab. To give you the context, I documented everything, and I even explained the example of the attack and its mitigation. I'm going to show the examples now. And this laboratory is a cloud run. That's the new thing. The advantage is that if you wanted to organize a training, the participants don't have to install anything in their machines. It's an Aruba switch, a key router, and the attacker, and consistent with what Alejandro Costa said this morning, we should not neglect security in our corporate LAN. Sometimes we focus too much in the border. We are very worried about the outside and not the inside. So why did I choose this switch? It's because of all these machines where you virtualize the real operative system, this one specifically was the one that wouldn't create any constraints when installing snooping. It made it possible to establish a filtration rules, so that's why I chose this. This is my device. I'm already logged in. My device, Aruba. After configuring this snooping, I can see the bindings of global unicast, link local with their MAC address. So the first example that I propose is middleman attack, man in the middle attack via neighbor spoofing. That is, when the host sends a query to the server, the router needs to know the layer 2 address and executes the ICMP, version 6 to know what the link is. And it is there that the attacker attacks with its MAC address, but with a fake unicast, a global unicast address of. So that is the aim of the attack. In my PC1, this is the attacker. I'm going to enable the forward and executing from, well, here I have everything. From my PC3, I query, here I did it with HTTP, but it could be with HTTPS. But before that, I should capture it in the attacker's host to verify that that falsification was done based on the protocol. So let me go on with my PC1. This is what in IPv4 we know as poisoning, cache poisoning, RP poisoning. And so there you have the attack. It was launched. And now from PC3, I send a query to that app, to that service. And here I should see the attack packets. Indeed, we can see it. I'm going to stop a minute so that we can check it, so that for you to see. Let me go back. The client was not affected, actually, in spite of, well, he could check on the website, and from PC1 the announcement is made that truly the attack did take place, and informing that they responded to the link local address of and falsifying the IP of this device that sent a query. Let's see whether this is right. If I see, I can check in the bindings. Here, PC1, it's connected to port 2. Its MAC ends in 620F. It's so difficult here with this rostrum. Now, here 620F, that is PC1, and IPv6 global with PC3, if config th1, for A05. I can check that here. This traffic that I captured in PC1, you can clearly see that it's that this was done by the MAC PC1, but reporting or announcing the IP of PC3. So, how can I see that this was mitigated? Because here I have the possibility of consulting the statistics, and it is reported that there was a drop, a validation drop of the neighbor advertisement that are not permitted. So these are DDoS based on plugin and flooding. And here there's a detail, because not all the neighbor discovery and snooping can protect us or filter, because there are many attacks using either protocols such as time Z, packet 2B, that are not mitigated with this snooping of a third layer. So there I have to configure filtration rules, and there are even variants that using extension headers allow them to mask this, introducing the extension headers. So now I'm going to capture this in the router, because the attack will target the router directly. And from PC3, in this case, let's do TK flute unreachable with a variant -F to put those messages unreachable in the fragmentation extension fields. So EH1, EF. Oh, they changed this. So there you have, the attack was started. I captured this. Oh, well, I am actually. I am capturing this in the router. Those packets are not reaching destination. And how can I check that they were mitigated? If in my switch device I can see the entries of the dropped packet because of with the rules. Gate counts IPv6 sec, and there I can see that I have 1,359 packets that were dropped because of that unreachable attack. Is that okay? So the last attack is similar, just that we're going to use time exit packets. The attack is called resource exhaustion. In exhaust 26 -TR, this it is capable. It can cause more damage because it does a random. It attacks the origins randomly. So the router, if I don't have the ASLs, the router consults those new origins, those new hosts that are connected to the network, because we are going to see that live. And so this attack is done across the network. It can be the local one or another one. Let's see, 2001. Well, there you have it. So it's a prefix. There, the attack was started. And I can visualize this.
I can visualize this in my SSLs. These were dropped. Here it is, 1772 messages where the ICMPv6 type is 3, and 3 corresponds to the time exceeded code. Finally, to verify that in fact the attack is exiting, I'm now going to change the capture. I'm going to do this on the host that does the attack, and I'm going to repeat with the same example, because we always did the capture in the victim host, and we showed that this was not filtered, although I showed you in the switch that it was mitigated. But the interesting thing is to do the analysis from the host that carries out this attack. So we go over here, and there it is. And there we are, live. There we see how this is done randomly with the origin addresses, so the router tries to find out and sends messages, neighbor solicitation messages for each of these addresses. There it stopped, and you will note that this was just a second. I did Control B. If I would have left it 1 minute, it would be devastating. So the entire configuration is available. This presentation, this example is available for use. These are open source tool, Container Lab open source. The images are also open source. And in fact, this switch specifically, the one on Aruba, is a Kimu image that runs in a container using an extension Kubernetes Lab. It's like deceiving the Docker. So we have a VM between a Docker. Nokia is fully Dockerable, so it's containerized. And the beauty of this tool is that the entire configuration of the devices we do running when we do the topology. This is the configuration of all the security aspects, and we can see that this is a whole set. Through secure, I limit the number of clients. We have the access list. It is the neighbor discovery snooping is enabled. So you can close, Henry. If you allow me to clarify something, this type of command and attacks was done with an objective, an educational objective. We are showing you this in the laboratory internally. What we can see here is how important adding this ICMPv6 protocol, which is different from the version 4. So this gave this much more importance. That is why we highlighted the importance of ICMPv6 in a local network. So the purpose of this work was to be able to filter, because we realized that there is a lot of slack exploitation that comes from ICMPv6. This demonstrates what my colleague was showing. So proper filtering produces a more secure network. Now let us close with the final 2 slides. You can continue.
Bueno, esto es el detalle completo de todo lo que se probó.
So this, I shared with you 3 examples. The order in which they are here has an explanation. What is ND snooping? All these attacks are mitigated by ND snooping plus a combination. You have the details here. And the last ones, the flooding, is a combination of all plus the ACL filter. These are the examples I gave you. Now the point is that I already announced this when I made my presentation. There's not just one mechanism, so it has to be a combination of various mechanisms. ACL filters through secure. Now recommendations. Have the practice of always reading the latest RFCs, the vendor data sheets. We'll have to bear all these things in mind, as well as the testing I can conduct in the virtualized environment, so that the vendors are aware of what the device should allow me to configure to have a secure network. Apply policies and procedures based on resource combination and the potential that the devices can offer. And if we have to add to that, because we're never sure, there's no system that is 100% secure, we have to add traffic monitoring. I have another lab where I could integrate NTOP NG. I could monitor that with Suricata. And so be able to know all the ICMP traffic that is generated in my local network to be sure that I'm not subject to attacks. Thank you.